This is Unit 9, Lesson 3, Adding and Subtracting Rational Expressions. I'm going to start this off by reviewing how to add and subtract fractions, because when you're adding and subtracting fractions, you need to understand that you need a common denominator. So in order to get a common denominator here, what I need to do is ask myself, what do 5 and 3 both divide into? So I'm looking for the least common multiple between 5 and 3. Another thing I could do is say, okay, what do I need to multiply 3 by to get something that 5 will go into? And here, the simplest denominator that we can possibly have is a 15. 15 would be the least common multiple. And you've done enough math now that that should not be too difficult for you to understand at this point. And then to get my new numerators, what I have to do is I have to ask myself, what did I multiply the 5 by to get 15? Well, I multiply 5 by 3 to get 15. So that means if I multiply the 5 by 3, I also need to multiply the 1 by 3. So that I'm changing what the fraction looks like, but I'm not changing its value. So if I multiply both of those by 3, I will have 3 over 15. Here, what did I multiply 3 by to get 15? Well, that's 5. So I'm going to multiply the top and the bottom by 5. Essentially, I've just multiplied by 1. 5 over 5 is 1. So I'm changing what the fraction looks like, not what the value of the fraction actually is. So if I multiply 2 times 5, I get 10. So 10/15 is the same thing as 2/3. It's just not simplified anymore. And so then I'm going to add these together. Now, when I add fractions with common denominators, I keep the denominator the same, and I add the numerators together. So that gives me 13 over 15. If that would simplify, I would simplify at this point, but that doesn't simplify. That's all I can do. Now, when I'm dealing with algebraic fractions, I need to do the same thing. I need to get a common denominator in order to add the fractions together. This one has an x, this one has a y. So they both need to be exactly the same. So I need to multiply this one by a y because this one has a y and the first one does not. So I need a y over here. If I multiply by y on the bottom, I have to multiply by y on the top. Essentially, I've multiplied that fraction by 1, not changing its value, just changes what it looks like. Over here, I have a y, but I need the x. So on this one, I'm going to multiply by x on the top and on the bottom. Doing that gets the denominators to be the same. I multiply the top and the bottom so that I don't change the value of the fractions. Now I can add these together. Y plus 2x over xy would be my answer. There's nothing that cancels out there. If it would simplify, I would simplify it, but at this point, that's all I can do. For this one, this is 2 over 3x squared minus x. That's understood to be over 1. This has a 3x squared. This one needs a 3x squared. So I'm going to multiply the top and the bottom by 3x squared. I can get rid of the 1 because 1 times anything is itself. So the 1 doesn't really need to be there. Now that I've got the denominator the same, this one is 2 over 3x squared minus 3x cubed over 3x squared. And now I subtract those from each other. So that's 2 minus 3x cubed over 3x squared. Nothing cancels out there. That's all I can do. That would be my final answer. For this one, I have a denominator of a here. That's understood to have a denominator of 1. They both need to have an a on the bottom. So in order to force this one to have an a, I'm going to multiply the a on the top and on the bottom. So a times a is a squared over a minus 1 over a. There's nothing else that needs to be done on that one. I can leave it the same. And then I would subtract. I've got a squared minus 1 over a. I cannot cancel the a's because this a squared is attached to the one with a subtraction. That's all I could do here. It's tempting to factor difference of squares here and get a plus 1 and a minus 1. There is no need to do that though because it's not going to help you simplify the fraction anymore. So I would just leave it like this. This one has a y, so this one needs a y. I'm going to multiply the bottom and the top by y. This one has an x squared. This one needs an x squared. So I'm going to multiply the top and the bottom by x squared. This is understood to be x to the first. So on top there, I have x cubed over x squared y minus y over x squared y. And then I subtract those from each other, giving me x cubed minus y over x squared y. And that's all I can do for that one. Over here, this one has a 2x squared. This one needs a 2x squared. So I'm going to multiply by 2x squared on the bottom and on the top. This one has a 5 on the bottom. This one needs a 5. So I'm going to multiply by 5 on the top and on the bottom there. Then I'm going to multiply what I have. So I've got 5 over 10x squared minus 8x squared over 10x squared. Now that my denominators are the same, I can subtract. I keep the 10x squared and I subtract 5 minus 8x squared. If anything would factor out, I would factor and simplify, but in this case, nothing does. Sometimes you're going to have pretty complicated rational expressions that are added and subtracted. When I'm doing ones like that, the first thing I do is I'm going to factor out everything that can factor first, see if anything cancels out to make it simpler, and then go from there. A lot of times if you don't factor things out first, it makes the fractions more complicated and you're not able to get your answers very easily. So what I'm going to do here, the x plus 10, it won't factor. Here I can bring out a 3. So I'm going to bring out the 3, that leaves me with x minus 5. On the top, I can bring out a 3, that leaves me with x plus 5. And on the bottom, I can bring out a 6, and that leaves me with x minus 5. Now, looking at the denominators, I know in order to be able to subtract these, my denominators have to be the same. Well, I might not have seen this if I hadn't factored, but they already both have an x minus 5, so that makes it really nice. This one has a 3, and this one has a 6. So technically, this one has a 3 and times 2. 6 is 3 times 2. So this one has a 6 times x minus 5. This one has a 3 times x minus 5. To force them to be the same, I need to multiply this one by 2. If I multiply on the bottom by 2, I have to multiply on the top by 2. So I multiply bottom and top by 2. That leaves me with 6 times x minus 5 on the bottom. 6 times x minus 5 on the bottom on the other side. On the top here, I have 2x plus 20. And here, I have 3x plus 15. Then I'm going to subtract my fractions. To do that, I keep the denominator the same. 6 times x minus 5. And then on top, 2x minus 3x is negative x. 20 minus 15 is positive 5. Make sure that you're subtracting both of these terms. It's very tempting to do 20 plus 15, but that minus does distribute among both terms there. For the next one, this one has a b on the denominator. This one needs a b. It's understood to have a 1 right now. But that 1, if I multiply it by b, will be b. So I multiply the top and bottom by the b. And then I have 1 minus ab over b for my final answer. For this one, I want to get the common denominators. They both have an a squared. This one has b cubed. This one has b. So this one needs 2 more b's. So I need to multiply the top and the bottom by b squared to force this to be b cubed so that they will be the same. So I have 1 over a squared b cubed plus b squared over a squared b cubed. And then I add everything together. So I'll have 1 plus b squared all over a squared b cubed. For this one has a 2, this one has an 8. To make this 2 and 8, I'm going to multiply it by 4. So I'm going to multiply the top and the bottom by 4. And then this one also has an x squared, so I need an x squared over here. So I'm going to multiply the top and the bottom by the x squared, leaving me with 20x squared on top over 8x squared minus 3 over 8x squared. Now that my denominators are the same, I keep the denominator and I subtract the top. So that's 20x squared minus 3. Nothing will simplify there. I cannot cancel out the x squares, remember, because this one is attached with the subtraction.